Hi, welcome to this Discrete Math presentation on game theory. You probably didn't expect to learn about games in math. So let's start by defining what exactly is a game. Well, there are a lot of games that you've probably played. It can be a board game, a sports game. What we're looking at specifically is these games, we must have two or more players. Strategy needs to play a role. And basically, there has to be an outcome. Someone has to win, someone has to lose. Now, when we talk about strategy, there are some games that obviously don't have much strategic interaction. There are games that are purely chance. So, like lotteries, slot machines, flipping the coin. Basically, the strategies don't matter. Also, we're looking at strategic interaction between players. So if it's a single person game like solitaire, there might be strategy, but it doesn't have strategic interaction. So believe it or not, game theory has a lot of applications, which is why we're studying it in a math class. We're going to look just at one application in economics. So in economics, we have strategic interaction. So I would have a strategy as a business owner and how I'm going to market if I was owning Coca Cola versus Pepsi. There's also strategic interaction when you're at an auction and you're bidding on something. Game theory would apply in things like negotiations. So, either negotiating a contract or internationally, like trade agreements. And then also in setting a price for a product. Investments also have strategic interaction. So the stock market or how you buy, when you buy a house or a car. So other applications of game theory, there's definitely a lot of game theory in politics. So who should you vote for? A politician might debate how they should vote on an issue. It's a lot more complex than just what they believe. What will be the consequences based on their vote? Cryptocurrency, or in a legal case. So, in game theory, there are a variety of elements that we have to consider. We need to know how many players there are, what role chance or luck has, what are the different actions or strategies that we can take, what information do we have when making a decision, what are the consequences? So, what's going to happen as the result of my move in a game? And then, what are our priorities? Now, when we play a game, there are two different types of games, a zero sum or a non zero sum. Most typical games that you either watch, like sports, or that you play, are zero sum games. Basically, our interests are in conflict. So one team is going to win, one team's going to lose. So one win minus one loss, that equals zero. Like they balance each other out. A non zero sum game means that our interest might not be in conflict. So it's possible that we could both win, have some benefits, or it's possible that we could both lose. So, for example, you might play a game of chicken where your cars are driving on each other. And if neither one swerves out of the way, they're both actually going to lose because they're both going to crash. In business negotiations, it can be a non zero sum because if we compromise, we might actually both have positive benefits. Relationships are a non zero sum game. Hopefully, there's not a winner or a loser. And one we're going to look at more later this week is called the prisoner's dilemma. In the prisoner's dilemma, what we have is two players, or quote, two prisoners. And each prisoner has two choices. They can either confess or they cannot confess. Now, the consequences are based on the actions of both prisoners. So if I confess, my punishment isn't based just on me, it's also based on what the other prisoners does. So if we both confess, we both get 5 years. If one player confesses and the other one remains silent, the confessed person actually gets 0, but the one who remains silent get 20 years. If we both remain silent, we each get 1 year. In the prisoner's dilemma, we each have to make a decision without knowing what the other person is going to do. A non-zero sum game application applies to the nuclear arms race, when we're trying to settle a dispute and we're kind of debating, should we hire a lawyer? Currently in politics, as we talk about the debt ceiling or passing a new budget, that's a non-zero sum game. Again, we could all lose or we could all have some winnings. Another way we could differentiate games is that they can either be simultaneous or they could be sequential move. So if people are playing at the same time, their strategies are simultaneous move games. So, for example, in the prisoner's dilemma, we were both making a decision at the same time. In a war card game, you both put down a card at the same time and then reveal. In these cases, it's hard because we're trying to predict what our opponent will do. Mini games are sequential. So you choose your actions based on the previous actions of your player. So, for example, in chess, you're going to look ahead and try to make plans, but you also know what your opponent just did. And there are often a lot of these applications that include both types of situations. Games can also be one shot or they can be repeated. So, a one shot, obviously, the game occurs just once, and very likely the players don't know very much about each other. Now, when it's repeated with the same players, you learn more about your opponent each time. So you can predict things. And since we know each other, we might actually become cooperative. So if you're playing a game and you're wondering what kind of strategy you should use, how aggressive you should be, one thing you might want to consider is whether this is a one-shot game or if this is a repeated game. If it's a repeated game, you probably don't want to use a super aggressive strategy. So, for example, in a sports game, you probably don't want to win by as many points possible and really show up that team. You have to consider what the future consequences of those actions are going to be because you know you're going to see that team again. So, strategies can change when we have a repeated game. A strategy is just a plan, and it's a plan based on the past history of the play. There are different strategies that are going to come about in a repeated game because our strategies might depend on the actions chosen previously by that team. So, one thing we might have is a trigger strategy where what we do impacts what's going to happen next. So, for example, in the prisoner dilemma, if we both don't confess, We each only got 1 year. So if we're playing and neither one of us confesses, we might know next round, well, like that's what we're going to do again. However, if my opponent confesses, well, then I didn't do well because of that. So probably next time I am going to confess. And finally, there are some assumptions that game theorists make. We're going to assume that all players behave rationally. So we're going to assume that each player's goal is to maximize their payoffs. And we're also going to assume that the rules of the game are common knowledge. So that each player knows the set of players, they know the strategies, they know the different combinations that might result. You'll learn more about game theory throughout the rest of the week.